Okay, you're getting close to the end. We've only got 3 more examples left, and they're all kind of interrelated. So F, again, we start by identifying A, P, and Q. In this case, A is positive 2. P is non-existent, so it is 0, and so is Q. So my vertex actually is at 0 and 0 again, just like my parent function was, that very first one that we drew. So it's opening up because A is positive still, so we're dealing with the minimum at y equals 0. So my range is from 0 and upward. My axis of symmetry is at x equals 0, but otherwise it is unrestricted. Always your smaller value first, and then your larger one for domain and range. Again, I can solve for my y-intercept. Y equals 2 times 0 squared, which is still 0. So that's nice. Y equals 0. I'm going to put this on my graph, and I'll figure out my x-intercepts from there. Same scale as before. Label x-axis, label your y-axis, 0 and 0. Now, this time we do have a vertical stretch. How that impacts my graph is that originally, but then we've got 2f of x is happening in my new graph. So whereas 0 stays 0, because 2 times 0 is still 0, when I put in 1, before I would get out 1, now I'm going to get out 2. It's doubled. Before, when I put in 2, I would get out 4. Now I'm going to get out 8, because it's doubling. That's what that A has an impact on. So when over 1, I would go up 2. Over 2 up, not 4, but 8. If I went over 3, I'd have to go up not 9, but 18. So I'm already off my graph again. So if we compare this to our previous example, if we look at those two graphs at the same time, we can visibly see that this one is narrower than the previous one. So that's what that value of A being bigger than 1 does. It makes it a narrower, taller graph. Now we look back for our x-intercept. I'll zoom back in a little bit here. And we see that x equals 0. For G, similar impact, except A is no longer a whole number, but it's a fraction. So it's going to fit into that other category of being between 0 and 1. But P and Q are both 0. So a lot of this fills itself in again. X equals 0, minimum, because it's still positive A value at y equals 0. My range then starts at 0 and goes upward. My domain is unrestricted. And my y-intercept is going to be a half times 0 squared, which is still 0. Okay, so this is looking very familiar. Almost exactly the same. So what's different? Well, that half is going to impact our values. So I'm going to make that little table of values up here again, just as like a reference point. So my original parent function, 0, 0, 1, 1, 2, 4. 0 times a half is still 0, but 1 times a half is now a half. And 4 times a half is now 2. And it's going to continue on forever. 3 would have produced 9 originally, now it's going to produce 4.5. Okay, so when I go to graph this, I'm going to still, now, I do not recommend in actuality, if this was the only function that we were graphing, that you would keep your scale the same. I would make it much bigger. But because I want to be able to visually compare it to our previous graph, I'm going to keep my scale the same. But under normal circumstances, I would definitely alter my y-axis because I'm dealing with much smaller y values. vertex is still at 0, 0. I'm going to go over 1 and up just a half. So I'm barely leaving that x-axis because even halfway up is 1. Okay? Over 2, I should only be going up a total of 2, not 4. Over 3, up 4.5. Over 4, only up to 8. Okay, over 5, and I actually can go to 10, 12 and a half. Should be here. So I'm getting a lot more points in here. And when I graph this, I'm going to still make it a curve. And you want to try and make it as smooth as possible. I struggle with that using the surface. Now, if we look at this compared to our previous graph, it is definitely much wider. And so that's the impact of the half versus the 2, is that width of the graph. But I look at my graph and my x-intercept is actually still 0 because I didn't have that p-value. It didn't shift. And it didn't shift my y-value either of my vertex. So no shifting means still my intercept stayed the same. Now our last example is negative a. A is negative 1. P and Q are still 0. So my vertex is 0, 0. My axis of symmetry is x equals 0. My graph, though, is opening down, which means that I'm going to actually have a maximum. Okay, it's a little sad graph instead at my y value of 0. So my range, instead of starting at 0 and going upward, it's going to go all the way to negative infinity. It's going to have a lid on it at 0. My domain still can be anything. There's still nothing that I'm not allowed to put into my equation. My y-intercept, if I plug it into my equation, negative 0 squared is still going to be 0. So that part's nice. But then we've got our x-intercept, and we'll see that on the graph as well. But we might already have a guess based on the lack of shifting around. So in this case, I'm still going to make that table of values as a point of reference. So we've got x and f of x and negative f of x. So if we go 0, 1, and 2 again, 0, 1, and 4 is what our expected outputs from our parent function, which is x squared. The negative version of that is going to be 0, negative 1, and negative 4. So we're going to be going downwards instead of upwards. Again, I'm going to keep the scale the same just for consistency and comparing sakes. 2 and negative 2, y and x. Okay, always label all of that information. From here, I'm going to put my vertex, and I'm going to follow my pattern. Over 1, down 1. Over 1, down 1. Okay, over 2, down 4. Over 3, down 9. And I run out of room at that point. So sometimes I find turning my page helps me draw the upside down ones. Otherwise I struggle. They start to look a little bit more V-like. And so that's the only difference. So relative to this guy here, it's actually the same width. Okay, so when a equals positive 1, it's flipped upside down. It's narrower than when a equaled a half, but it's wider than when a was 2. And my x-intercept is 0. Okay, so definitely practice working with vertex form. It is so incredibly helpful. Definitely practice graphing, practice identifying all these properties of quadratic equations.